In this video, we're going to focus on adding an interactive smooth to an existing scatter plot. We're once again going to use the penguins dataset from the Palmer Penguins package to illustrate our examples. We're first going to do this through the ggplot2 package, and then secondly, we're going to natively do it through the plotly package. So how would we do this through ggplot2? The first thing we need to do is to create a scatter plot with a desired smooth on it. We provide the penguins dataset to the ggplot function to create our ggplot. We then add a point geometry associating bill length with the y aesthetic and body mass with the x aesthetic. We also use the species variable in the penguins dataset to scale different colors and shapes to the different observations in our graphic. The next step is the critical step for getting our smooth. Specifically, we use geom_smooth to add a smooth to our existing graphic. We are going to smooth the relationship between bill length and body mass for our penguin data, distinguishing the different smooths by species. When I add color equals species into this aesthetic for geom_smooth, ggplot2 is going to fit a separate model for the observations of each different species. Once I have created the desired graphic, I assign it the name ggsmooth, and then I use the ggplotly function from the plotly package to turn this into an interactive graphic. Our plot displays information associated with each species when we hover over an observation, but more importantly, we have information related to the regression line associated with each species. So we can see here we have a regression line for the chin strap penguins. And as I move along this line, I can see, for example, that right here, the regression line has a body mass of 4,374.684 grams and a bill length of 51.69707 millimeters. Because there are confidence bands associated with this line, if I move up, I can see that the confidence band at this point is 4,401.27 grams, 53.23 millimeters. As I move along my confidence bands, I can see how these values change. How would you do this natively using the plotly package? Adding a smooth to an existing plotly graphic is a little bit more difficult than it was for the ggplot2 approach. The main reason it's more difficult is you have to manually compute some of the information you're going to need for your plot. Specifically, you're going to have to manually compute the smooth, extract the fitted line that you want to plot, and then add the fitted lines as a layer to an existing scatter plot. We illustrate this in the code below. First, we fit a separate lines regression model to our data. I don't want to talk in detail about this model, but it's going to allow us to fit a separate regression line for each group. An important aspect of this fit, though, is that I specify na.action equals na.exclude. The reason for this is that there are na values in my penguins data frame, and if I don't do this, then I'm going to have an issue when I try to get fitted values for my model. Having fit the model and assigning it the name lmod, I now use the fitted function to extract the fitted values associated with each observation. I then store this as a new variable in my penguins data frame. The fitted value of an observation is going to lie on this associated regression line. So if we connect all the fitted values associated with a group, then it's going to result in the fitted lines that we want. I now have all the information I need in the penguins data frame. To add our regression lines to an existing scatter plot, we first create the scatter plot we want to overlay our regression line on. We showed this in a previous video. I then pipe that scatter plot into the next layer of my graphic, which is going to be the regression lines I want to overlay on the existing plot. The add_lines function is going to add lines to an existing plotly graphic. I supply the function with the penguins data frame. I then want to connect the fitted values for each observation as we move left to right according to body mass gram. Because I want a separate line for each species, I'm going to specify color equals species so that I draw separate lines for each species with a corresponding color. And each line is going to have a different color. I also need to specify inherit equals false because otherwise this function is going to look to the original plotly function for the roles of different variables in the graphic. By specifying inherit equals false, all the information in this function is self-contained. The result is shown below. We once again have a scatter plot that indicates the body mass and bill length of each observation as well as its associated species. But we also have the fitted lines shown on the graphic, the regression lines. And as we move from left to right along the regression lines, we can see how the X and Y values are changing.